Good morning, one and all present here. Myself, Dr. P. Janagarathinam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different types of cam followers, and how we are constructing the cam based on their specification and types and all discussed. Today, I am going to discuss about the topics which is related to the gear trains, and gyroscopes, and what are the basic gear terminologies and fundamentals which will be applied for our gearing in mechanical concept. So, first of all, why the gear is matter? The gears are the backbone of mechanical power transmissions, converting torque and motion between the rotating shaft. Most widely used these kind of gears are automotive transmissions, industrial machineries, precision and power tools, and other applications which will be available in a mechanical field. This is the some of the key components of gears, like pitch circle, pitch diameter, addendum, dedendum. So these are all are the some of the basic gear terminologies which will be used to make the gears, and based on these terminologies we have to classified into many types of gears. So tooth profile and pressure angle. We have to consider the involute curve, the industry standard tooth shape that guarantees the what kind of velocity ratio during the meshing of two gears, and these mathematical curves ensure that the optimal power transmissions between these two moving parts. The pressure angle we have to maintain the 20° to and 14.5° based on their applications and necessity. We have to consider these two kind of profile and the pressure angle. So important dimensions like face width and root diameter, backlash. The backlash, which is the small intentional gap between the meshing teeth, preventing the binding, jamming, and allowing the smooth operation between the two moving gears. So clearance, this is the space between the two tip and the matting gear roots, accommodates the thermal expansion and the manufacturing tolerances. These dimensions work together to ensure the reliable, efficient gear operations between the two moving parts, as well as the under various loading conditions, because we have to use this kind of gears for many applications. Based on their applications and the temperature conditions, it can be slightly modified. So this is the some of the gear types overviews. So spur gear and helical gear, bevel gear and worm gear. The spur gear straight teeth, parallel shafts, and the helical gears are angled teeth for smoother, and bevel gears are having the conical shape, transmits motion between the intersecting shafts. Typically it can be maintained the 90° angles. And worm gears, it's like an screw like design, provides the large speed reductions with the high torque multiplications in the compact specifications. So this is the gear ratios. The formula which will be used to calculate the gear ratio is the ratio between the teeth on the driven gear to the teeth on the driving gear. So this is the one small examples we have to calculated the gear ratio. The ratio means the output shaft completes one full revolutions for every two rotations of the input shaft. We are having the input and output shafts. Every two rotations of the input shafts, the output shafts will complete the one complete revolutions. Based on these formula and calculations, we have to calculate the gear ratios. So the larger driven gear means it can increase the torque output, decrease the rotational speed, and perfect have the heavy loads. It is which will be applied for the heavy load applications. We have to use the smaller driven gear means it can decrease the torque output, it can increase the rotational speed, and it is ideal for the high speed applications. The real world applications of these kind of gears are like automotive transmissions between the multiple gear ratios to optimize the engine power across the different driving speeds. Okay, so this is the meshing and conjugate actions. The meshing means how the two gears are mating properly. Based on this meshing only, we have to give the proper output. So this is the practical considerations while making this kind of gear. backlash and clearance, design trade-offs, ideal gears, and maintenance, which is the essential for the gear operations. So this is the mastering fundamentals like core principles, like gear converts the speed and torque through the precise tooth geometry, and essential terms like which will be considered as the important terminologies like pitch circle, addendum, dedendum, pressure angle, backlash, and clearance. So applications are different gear types of the specific mathematical and mechanical needs and SAP. So this is the explore the gear design principles, load calculations, and the real world applications in the engineering fields. Okay. So this is the general mind map of this today video. We have to discuss about the gear types and technologies, and here the terminologies will be discussed, and how we are doing this manufacturing process of gears, and how we are considering the different angles, dimensions, and other terminologies which will be considered to make this kind of design process. This is the small two assessment quiz based on their gear mating as well as gear types. This is the some of the reference which will be used to make this kind of PPT for the mechanics of machines. So thank you.